Hello everyone, in this tutorial we are going to take a look at how I make my preview materials inside Blender using Substance Designer outputs. So this is my cliff rock material, and as you can see I am passing all the final outputs inside a base material, so I can have a good preview of the material here inside Substance Designer. And this is kind of the result. And for my outputs, I have a diffuse map or an albedo map. This is it. Then I have my normal map. This is a pretty strong normal map, but in Blender we are going to divide its intensity a little bit to have a more soft normal map. Then I have my packet maps in this texture. I am using roughness, metallic, ambient occlusion and height to make a single texture, which is this. And then I have my OpenGL normal map version, because I am going to use this inside Blender. And I think that's all. So I am exporting 4 maps. As you can see, I am exporting my maps in a 4K resolution, because for a preview rendering material, this is going to be a good resolution. Okay, let's go inside Blender now. This is my sphere preview model. This is actually my UV unwrapping. It's just so every phase has a complete 0 to 1 UV space spread of the texture. Then I have made some subdivisions, as you can see. And finally, let's go in my 3D view. Finally, you want to activate some experimental features sets inside Blender. So you just need to go into the Render tab and activate the experimental feature set. Then go inside your World tab and load in some HDRI images. For my setup, I am just using a single photograph, because we are not going to preview all that reflection details. So I am just using a normal forest photograph. In the Modifiers tab, you want to add a subsurface modifier, and as you can see, when you enable your experimental feature set, this modifier is going to have some more settings. In this case, this is an adaptive subdivision modifier to have a great tessellation inside the render view. So my dicing scale is set to 1. Here in the bottom, my rendering tessellation size is set to 1 pixel, and my preview tessellation size is set to 8 pixels. So the polygon is going to be the size of 8 pixels inside my preview and the size of 1 pixel inside my render. And you can actually tweak this value from the rendering tab and the geometry section. In here you can see that we have a preview of 8 pixels, and we can tweak it to have some better preview renderings here in the viewport, or we can take it just as it is, like 8 pixels, so we have a faster preview rendering. Inside your material tab, you want to set displacement method to displacement only for now. We are going to try with that kind of displacement. Usually it works without problems. And then we can start to build our material. Actually, before that, I am going to show you my light setup. These 2 satellite spheres are just light emitters. This sphere has an emission shader with these colors set on 1000 on strength, and this is just illuminating my main sphere. As you can see, if I move this, my preview rendering is going to change. For the upper sphere I have a white color and some lower strength, but usually I am going to tweak these when I am rendering, because depending on the material you are working, you maybe want different light sources. So let's start to build our material. The first thing that I'm going to do is delete the diffuse shader, type Shift A, and add a principled BSDF shader. Now I am going to connect this to the output, and we can start to work with our custom textures. Let's add a new image texture, and we can connect this to the base color right away and hit the open button. Here we have the diffuse map, so I load this in, and this is kind of the base result using this map. We also need to load our roughness and all our maps, so let's duplicate this a couple of times, and we can now load our normal map. I'm going to load the OpenGL version, which works good with Blender. You want to pass your normal map inside a normal map node, so let's add that node. You want to go into vector and add the normal map node. Then I am going to switch the type of map to non-color data, and I'm going to hook up this output to the normal map input, and we can now connect the normal map. So the next thing I'm going to do is load my packet maps texture. They are ordered just like the name, so the R channel is going to be roughness, the G channel is going to be metalness, and the B channel is going to be my occlusion map, and the alpha the height map. So let's go into converter and separate RGB. We can hook now the maps inside the image input of the separate RGB, and the roughness is going to be the R channel as we said. So let's hook that up, and maybe we want to preview these maps before, so we are going to be sure of what we are doing. Okay, let's add a new shader, a new emission shader, and try to connect our R channel to the color and the emission to the material output, so we can preview our texture. So I am going to pass my roughness inside a math node. So here it is. Let's try to multiply this by 6 for now. Then we want to start to preview some tessellation. So let's load in a displacement node. You can find this node inside the vector tab, and I am going to put this node right here, and we can now connect the displacement to the correct node. And the alpha channel of my packed texture should be the height. We can connect the alpha, and as you can see, we already have some displacement. I am going to set this to 0.25. Now we want to lower the roughness multiply level. I am going to connect the metalness to the right input of the principled shader. And for the last part, I am going to load a geometry input and connect my tangent to the tangent input of the principled shader. So doing this, we are avoiding some rendering errors. And now I am going to take a look at some details. And as you can see up here, we are encountering some seams. So you want to rotate the material until you can't see any seams of the textures, because the displacement material is making holes inside our model, as you can see in here. And you want to try to eliminate that kind of errors, or you can just make some model with a better UV unwrapping. For me this is kind of cool, so I am not going into detail. We are pretty much done. We just need to set up our light position, scaling and moving your light emitters. It is going to give you some cool results. You can also change the color of the light and achieve the kind of lighting that you wish. And you can also duplicate the lights. And make some more light sources. Now I like this material, so I think we're good to go, and we can start to try some rendering. So let's enable my GPU computation of the rendering. I am going to render my first preview to a 50% resolution and hit F12 inside my keyboard. Let's zoom in a bit inside our material so we can appreciate some details, and hit F12 again. I am quite happy with my detail level. As you can see, I have decreased my HDRI image strength, so we are going to have more contrast between the shadows and the lights. So let's hit the render button again. I am not really happy with my roughness contrast, So I think I am going to tweak somehow my roughness values. Let's try to do that. I am going to preview my roughness alone, and we can take a look at our roughness values in here. And let's see. I am multiplying my roughness map with itself, and then I am going to multiply again to add more rough surface. I am multiplying the output of my first multiply with a value of 2. I think this is better. Let's try to render this. So now we have more differentiation between our whites and blacks. So my albedo map seems too much gray, so I will try to multiply that map too. So let's add a mix RGB node and multiply the texture with itself. Let's preview the color map. This is the original map and this is the multiplied map. With a 0.5 value, we are achieving this result. Let's try and preview that. Okay, so it turned out that the plain roughness map is the better solution. So the original texture that I made inside Substance Designer, it is pretty cool. So I am going to use that for my final rendering, and everything else remained the same. So now it's just a matter of position your camera and position your lights. This is how I create my preview materials. So for the final rendering, we are going to set the resolution to 100%, hit the render button, and now we can appreciate our final material. For every material, you are going to need to set up some different nodes, because sometimes we don't achieve the result that we want, but it's just a matter of changing some textures by multiplying its values or dividing or something like it, and everything else should be working pretty fine with this default setup. After all, this is a PBR material setup. As you may think, every texture should be working as it is, and in fact, for the most part, that is going the result that you are going to get without tweaking anything. This is my final rendering. For this tutorial, it's going to be all, guys. If you wish to know more on how I do my materials, check out my previous tutorials about Substance Designer. Now I am making a worn asphalt material. I have already made my preview, so we can check that. I am just rendering it now. This is the result for the worn asphalt material. You can follow my details Substance Designer tutorials on how I made these inside my channel. My material setup is just the same. I have just added some velvet shader and hooked this up inside a mix shader to have some border accent of my light values. Everything else is just the same. Let me know what you think of this tutorial. If you need more information, let me know here in the comments. and I hope this is going to help your process. If you liked it, hit that button and consider to subscribe. If you have some other techniques that are better than mine, just let me know, so I am going to be happy to link your videos too. Thanks to all, and we see you in the next tutorials. Bye guys!